Excerpt from The Narwhal's Tale, Surviving Sea Ice Change by Caitlin Kennedy. In recent years, marine biologist Christian Ledra heard reports of large groups of narwhals dying in entrapments, where sudden shifts in the wind or quick drops in temperature rapidly freeze over the leads where narwhals surface to breathe. The whales are left stranded without even breathing holes to lead them to open water, and hundreds of them will squeeze into shrinking openings in the solid ice. Many narwhals suffocate and die while fighting for air in these tight spaces. Others become easy prey for polar bears and other predators that gather around the breathing holes. After many years of studying marine mammals in the Arctic, Ledre knows that entrapments are a natural casualty of living in such a harsh and dangerous environment. But some of the entrapments that have occurred in recent years stood out to Ledre. They were occurring during a time of the year when entrapments do not usually occur, and in locations where these events had never been observed before. The narwhals were found trapped in the vicinity of their summering grounds up north, even though ice entrapments occur most frequently during the winter when the narwhals are located farther south. Ledre began to wonder if these events were a sign that narwhals were being caught off guard by changing sea ice conditions caused by rapid warming in the Arctic. You can't ignore the fact that the Arctic is changing fast, Ledre says. As a marine biologist, I want to understand how these changes will affect the animals and their habitat, and whether they'll be able to adapt to changes in the future. One approach that Ledre and her colleagues at the Greenland Institute of Natural Resources take is to tag as many narwhals as they can by attaching a small satellite transmitter to their dorsal fins. Once attached to the narwhal, the transmitter gathers information about the animal's location and movements, how deep they dive, how much time they spend underwater, and sends data to satellites orbiting in space when the narwhals surface for air between the cracks in the sea ice. Using the data collected from the transmitters, Ledre has learned that narwhals are true creatures of habit. Many of the narwhals' biological patterns, when they eat, migrate, and reproduce, are orchestrated in tandem with the annual expansion and retreat of Arctic sea ice. In the summer, retreating ice allows narwhals and their newly born calves to access their summering grounds in the sheltered inlets, bays, and fjords along the Canadian Arctic coast and northwest Greenland. As fall begins and the coastal summering grounds begin to freeze over again, the narwhals move out and migrate southward. By mid-November, large populations of narwhals are gathered in the offshore areas of Baffin Bay and Davis Strait, where Greenland halibut, their main food source, are plentiful. Narwhals spend the winter in this region, virtually surrounded by dense winter pack ice, and diving to feed on halibut near the seafloor. The pack ice in winter works like a conveyor belt, forcing the animals to constantly move, Ledre says. The narwhals have the largest ranges and the highest velocities during years with extensive ice cover. In 2008, Ledre and her colleagues estimated that there were approximately 18,000 narwhals in their survey region. Most of that area, however, was covered in dense ice, and only 2% was open water available to narwhals for breathing. Narwhals are mammals and need air to survive, so they tightly pack themselves in stretches of open water and cracks called leads in the lighter, newer ice. The researchers estimated that about 77 narwhals were clustered below every 1 square kilometer of open water in the survey region. The frozen landscape can shift quickly. Changes in ocean currents, winds, and temperature can cause leads to open up and then refreeze again rapidly. Recently, even larger changes have been taking place in the narwhal's wintering grounds. Satellite data have revealed a 9 to 11% decline in sea ice extent per decade in the Baffin Bay and Davis Strait areas since 1979. Scientists have also documented the earlier springtime breakup of ice in Baffin Bay. The whales are used to living in the pack ice during the winter, Ledre says. We don't yet know what they will do if, in the future, the ice isn't present where it normally is. While sea ice loss would create more open water space for the narwhals, shifts in the melting and freezing cycles may alter their migratory, feeding, and reproductive patterns. Changes in the ice regime could also directly translate to changes in the Arctic ecosystem that could indirectly harm the narwhals. In the case of the recent entrapment events, if seasonal sea ice expansion and retreat patterns shift, will it change the narwhal's migratory timing? That's the question that Harry Stern, a sea ice expert and colleague of Ledre's at the University of Washington's Polar Science Center, could help her answer. Stern used satellite observations to examine sea ice patterns in the 6 largest narwhal summering grounds over a period of 31 years. He noticed that the annual sea ice freeze-up that takes place during the fall has been occurring progressively later with each passing year. In recent years, the autumn freeze-up has occurred roughly 3 to 4 weeks later than it did in the 1980s. This trend is a symptom of a rapidly warming Arctic region. The gradual loss in sea ice observed over the last few decades allows the water to stay open longer and absorb more heat, which prolongs the melting season. Because the narwhal's summering areas are remaining open for longer, one possible theory is that the whales are lingering there, delaying their migration south until later in the fall and winter. Suddenly, a very cold event, a large drop in temperature, or a shift in the wind, will freeze up a smaller area very rapidly and trap the whales, Ledre says. Meanwhile, because they've delayed their return, the larger area around them has already frozen over. So there are not many alternatives in terms of places to go once they're trapped. Ledre requires more data to further investigate this entrapment theory and determine whether the narwhals actually change their usual behaviors and linger longer due to the delayed sea ice freeze up, or whether these are just random events. But she feels she can conclusively and confidently say that both the narwhal summering areas and wintering areas are changing.